Okay, class. You guys had this for homework. Gave you an extra day to take care of this. Okay, so find the output for each input. Well, think about where do we input this right here when we're given these numbers? In the x. So, y is equal to 2 times negative 2 minus 4. Y is equal to 2 times 0 minus 4. And y is equal to 2 times 2 minus 4. And then we'll get some ordered pairs, okay? I've done this before, linear equations, even giving you, 3x plus 5, x equals 5, that's 20, those types of problems. So we should know what to do with these. Okay, so 2 times 2, well, 2 times the negative 2 is negative 4, minus 4, I get negative 8. So negative 2, negative 8. Where did I get this negative 2? That first input. Okay, so 0, 2 times 0, minus 4, that's 0 minus 4, or negative 4. Okay, 2, it's right here, I plugged it in. 2 times 2 is 4 minus 4, guess what? 0. So you're going to do the same thing with these three problems. You're going to write them down, replace the x with 2, 0, and 2 for all of these. All of these are using these numbers right here, okay? Now, determine if each relationship represents a function. Now, you can use different methods, class. One of them is domain and range. My domain would be everything over here on the x side, so negative 1, 9, 12, and 15. My range would be everything over here, negative 7, 1, and 8. Now, I'm not going to put negative 7 again because I already have a negative 7. So, 1 is equal to negative 7, 9 to 1, 12 to 8, and then 15 to negative 7. This would be a function because each domain, each one on this side, has only one value on this side. Now, it's okay that negative 1 and 15 both have 7 as its range. That's fine, okay? Now, what's a faster way to look at this? Well, I can look and say, okay, do any of the numbers on the x side repeat? No. If none repeat, my answer would be yes. It's a function because I'm only seeing this value one time. So it's not repeating, so it's not going to have a different y value. Okay. Another method would be, let's graph it. Let's graph it very quickly. Let me see how this looks. Okay, 1, 2, 3, 4, 5, 6, 7. I ran out of room. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Well, I'm going to run out of room. Okay. You know what? Sorry about that, class. I ran out of room. But if you were to graph it, you would see it makes a straight line, or a line that where if I put vertical lines, it will not fail the vertical line test. Now, to use a vertical line test, let's look at number 6. If I draw vertical lines here, now I'm going to try to line them up with the blue lines in the background in the grid. You'll notice that it only intersects the line that's graphed one time. Now, when I say only one time, I mean each of these lines is individual. So, did this line right here intersect this line going across more than once? No. If I put a line here, does that intersect more than once? No, it intersects one time. So basically, if it's a straight line like that, guess what? Yes, it's a function. But there's other shapes or other lines that I graph that can also be functions. For example, something like this. Or something like this, because if I put vertical lines, again, it's only intersecting one time. Now you have to be careful, because let's say you have something weird that looks like this. Well, everything over here will pass, but see how this line is straight? If I can put a line on one of the lines like that, guess what? It fails the vertical line test. So we need to be careful. We'll look at that a little bit more later. Okay, so the third one, again, look and check Do any of these numbers repeat? Sure, they do. I have negative 2 twice. So let me put a little line right here. Now, this first negative 2, see how I'm making the line bigger, has a negative 3. That means this one down here should have a negative 3, but guess what? It doesn't. So now this is not a function. So no, it's not a function. Now, right here, you're going to do the same thing. Again, if graphing it is easier for you and running the vertical line test, like this one, what do you think? Does it fail it? Does it intersect at more than 2 points per line? Yeah. So this right here, these problems, you could graph them and then check. Or ask yourself again, does the x repeat itself? If it doesn't, right away you know what to answer. It's a function. If it does, verify if the number across is the same or not. Now let's look at number 15 to answer that question again. Do these repeat? Yeah. 1, 4, 8, and 4. So 4 and 4 should have the same number across. 39, they should be either, no, they should be 39 too, but it's not. So guess what? It's not a function. No. Okay. So go ahead and use that information. That should help you. Let me go back to your notes. I'll probably make another video going into a little more depth in this. But just so you understand, this is what we're looking for with these questions. You have 3 different ways to answer if it's a function. You can use domain, where we have our little arrows, and do they match to all these? And does this one have more than one arrow? If it does, okay, then that's not a function. Does it have more than one range? Do the x's repeat? There's many different ways. And some of you might prefer to go ahead and graph it. Guess what? That's okay. The goal is to get the correct answer. And some of you might prefer to take this information right here, so I'm highlighting it, and go ahead and graph it, and that's fine. Okay? Any questions, see me in the morning, or go ahead and come by in the afternoon. Okay? Thank you.